Hey everyone, so this is one of your ISU lessons here. I think you'll find it a lot of review as we get going through it. Okay, so we're just looking at types of triangles, so just a little reminder. So you have a scalene triangle, okay, which means none of the sides are the same. Okay, and these are important to know because you will be asked to sometimes identify these or make reference back to them in your solutions. Isosceles triangle has two side lengths that are the same. Okay. An equilateral triangle has all three side lengths that are the same. Okay. A right triangle has a 90-degree angle. An acute triangle has all angles that are less than 90 degrees. Okay. And an obtuse triangle has one angle greater than 90 degrees. Okay. So just a little reminder, just to reference back to those if you need to. Okay. So angle properties. So just a reminder that opposite angles are equal to each other. So in this situation, this opposite angle, okay, would also be the same. And for B, this would be the opposite angle that are the same. We also have supplementary angles that add up to 180 degrees. So we know a straight line, okay, both A and B in this situation would add up to 180 degrees. So if you have one of those, you could also talk about finding the other one just based on that math. Another one to remember is complementary angles. Okay, they add up to 90 degrees. Okay, so for example, if you had A and B, they would add up to 90 degrees. Okay, and then we have some properties of parallel lines. Okay, so all they're saying in this situation is these two lines are parallel to each other, and we'll look at some theories. Okay, so alternate angle. Okay, so if we were to look at the inside here first to the outside here, let's label this C and let's label this B. Okay, we're saying C is equivalent to B angle. Okay, and we can also look at it as a different Z pattern where the Z works like this. Okay, and let's label this side A and this side D. Okay, where we could say A and D are equivalent to each other. And that's allowed because of the parallel lines. So that is why. Okay. We have the F pattern. Okay. So we'll work on this side first. So for example, the F pattern, let's go the insides. Okay. So let's label this A and let's label this angle B. So A would be equivalent to B. Okay. Now, the F pattern could also be an opposite F. So we could go on top here, like so. Okay. And let's label this C and D. So we have another example of the F pattern, and we know that the angle C is equivalent to angle D. Okay. And then the co-interior angles. Okay. So what we're saying about the co-interior angles is, for example, A and B. A plus B equals 180 degrees. Okay, so that's kind of like the idea of supplementary angles. Okay. And the same example would be with C and D in this situation. So C plus D would equal 180 degrees. Okay, so some of the things that are really important just from this introduction lesson is that you will be asked to use, okay, these names when you're solving. So you'll be asked to identify how did you come up with your justification of those angles. Okay, also please don't forget to use units. Okay, so don't forget your degree sign. Okay, super, super, super important. Okay. We just have a couple more solutions that we're going to look at. So just a reminder, the sum of all the interior angles of a triangle add up to 180 degrees. Okay, so that's the inside of the triangle. Okay. The sum of the exterior angles of a triangle, okay, add up to 360 degrees. Okay. So sometimes we'll be given information here that we might be given the exterior, might be given the interior, and we'll be able to solve for that in these situations. Okay. And then all we're saying is the exterior angle of each vertex of a triangle is equal to the sum of the interior angles of the two vertices. So what we're saying is we know a triangle adds up to 180 degrees. So X and Y would be the remainder would be of the 100 degrees would be this angle here, which is the same idea as using essentially the complementary angle formula. So finding 180 degrees, okay? So with some of that information, what we'll do is we'll look at some questions that we could solve, okay? There's no right or wrong way as you're going about this, okay? So you might start somewhere, someone else might start somewhere, that is fine, okay? For me, I'm just gonna start with A because it's fairly obvious. So if we want to solve for A, okay, we could use the complementary angle idea, okay? Okay, so we would know that A is equivalent to 180 degrees, subtract 49, okay? So we know that angle A, okay, is 31 degrees. And then what I would do is in your work, try to highlight that just so you're not getting confused. So then the other thing I would notice about this triangle is we're dealing with an isosceles triangle, okay? So you'll notice that we have two side lengths the same. So if we want to, now I would do, it's an isosceles triangle, okay? So I know that angle A is equal to angle B in this situation, okay? So we could also state that angle B is 31 degrees. And I'm justifying that because it's an isosceles triangle that's given to me, okay? Another thing I would look at is B and E, okay? We would call those opposite angles. So we also know that B is equivalent to E, okay? So we can also state that E, okay, angle E is 31 degrees. So without actually doing much math already, I've already solved essentially half that triangle. Okay. So now what we can do is we can look at the rest of this triangle. So let's solve for angle C now, okay? So we know that the sum of interior angles of a triangle equal 180 degrees, okay? So what we can do is we can take 180 degrees and subtract A and B to find out what C equals. I'm just gonna move this around. Okay. So 180 degrees, subtract 31 equals 118. Okay, so what I found is angle C equals 118 degrees. So notice my final answer always has the degree sign in it, okay? And I've stated how I solved that, okay? And then my last one would be to solve angle D, okay? Which is just a complementary angle. So then what we could do is angle D is equivalent to 180 degrees, subtract angle C. Okay. so angle D, okay, is 62 degrees. So again, you might not go about it in that order, and sometimes you might have different ways of solving it, and that's totally fine. So there is multiple methods. I just kind of work in order, okay? But you don't have to do it that way. Okay. In example B, they give us an exterior angle to solve for as well. But again, all we're really looking at is using complementary angles here. So for X, okay, we're going to solve by using complementary angle. So X equals 180 degrees, subtract 75. So we find out that angle X, okay, is 105 degrees. Okay. We can also use complementary method. So complementary, okay, angle for C. So C equals 180 degrees, subtract 135. Okay. So we find that angle C is equal to 45 degrees. And then the last one, because now what we have is the sum of the interior triangles, okay? We can solve, okay, for A. So sum of interior angles, okay? I kind of like to use just a short form, okay, because it takes so long to write out. So we know that a triangle's interior angles all up to 180 degrees. So now we can subtract the two angles inside, okay? And we find that angle A, okay, is equal to 60 degrees. Okay. Again, there's a couple of different ways to go about that question, so you can choose which way to go. So now that we've looked at some of the rules for triangles, we're going to have a quick look at some of the rules for quadrilaterals. Okay. So for quadrilaterals, the sum of the interior angles of a quadrilateral add up to 360 degrees. So that's the interior, okay? So it's essentially double that of a triangle. And the sum of the exterior angles add up to 360 degrees, okay? So those are some rules you kind of need to remember, okay? And we will be learning in the next lesson sum of interior angles of polygons. So you will get to learn a little bit of a formula for that, okay? So again, all they're asking us is to find the indicated angles based on the measurements. So as you'll see, we're giving a lot of complementary angles to work with. Okay, so complementary angle. So for angle C equals 180 degrees, subtract 130. Okay. So what we find out is that is 50 degrees. Okay, angle C. For D, it's also another complementary angle because it's on a straight line. So angle D is equal to 180 degrees, subtract 100. So angle D is equal to 80 degrees. E is a complementary angle. So again, angle E is 180 degrees. Sorry, just my equal sign. Minus 80 degrees. So angle E is equal to 100 degrees. Okay. So what we've done in this situation is we have found all the interior angles here. So 80 degrees, okay, 50 degrees, okay, and then 100 degrees. Now, someone might also notice that you were given all the exterior angles, so you could have solved for the exterior angle and then worked A first. You could have, there's a couple of different ways you could have done that, right? So I just chose to do complementary angles just because they stood out. So if I wanted to find out B, I would do the sum of the interior angles, okay? And I know for quadrilateral, they add up to 360 degrees. So now I would subtract, okay, all of my values here, okay? So when we do this, okay, so 360 minus 80 leaves us with a 280, 180 minus 50 leaves us with 130 degrees, okay? So angle B equals 130 degrees, okay? And now, again, if you wanted to, you could have used sums of exterior angles, okay? Or because we're so far in now on this way that we went, we can just solve it with the complementary angle idea, okay? So we know that 180 degrees subtract 130 leaves us with angle A equaling 50 degrees. Okay. So just take note too when we're dealing with parallel lines here, okay? So these all represent parallel lines. So that's a set of parallel lines and that's a set of parallel lines, okay? So we know with parallel lines, we can use our co-interior angle or our F pattern or Z pattern rules in this situation. So for example, you could use co-interior here, okay? So we know for that 180 degrees, okay? Subtract 115 degrees, okay? So angle C is equal to 65 degrees, okay? And now if you really want to kind of look at this, you could kind of look at this as, say, like a Z pattern if you really wanted to, okay? So our Z would fall like that. So looking at more sideways view, so what we're saying is, you know, A is equivalent to 115 degrees, okay? And I'll use a different color for this one. Okay, you could almost look at it, and do my Z correctly here. B and C, okay, are essentially, nope, sorry, that's not how I wanted it. Let me undo that, okay. B and C, essentially they're opposite angles as well, okay, across, but you could also talk about Z pattern, co-interior pattern, if you wanted to, okay. So we also know that C is equivalent to B, okay, and we have the C's, so what we can do is B is equal to 65 degrees, okay. So again, sometimes some questions really don't require a lot of math. It's just stating the different theories, okay. And we'll look at one more question. So again, there's a couple different ways you might go about this question. Okay, so in your assignment, you'll notice that there's going to be the measure and the justification. So the measure is the math, and the justification is what rule or theory you kind of use to solve it. Okay, so for T, okay, so we'll start over here. Okay, we're going to use complementary angle. Okay, so T is equivalent to 180 degrees, subtract 130, okay? So T equals 50 degrees, okay? And you're just gonna work your way around, okay? So X, okay, also complementary angle, okay? And again, you might choose to go about this question a different way. You might come up with different justifications. They're still right. You don't have to have the same justifications as mine as long as they make sense. So just solve for X. Okay, 180 degrees, subtract 117. So x, okay, equals 63 degrees. Okay. Let's look at S here. S is also a complementary angle. Okay. So S equals 180 degrees, subtract 95. Okay. So S equals 85 degrees. Okay. Now, V and Y, you would start by, well, you could start by solving sums of interior angles or sums of exterior angles. Whichever way you would want to in this situation would work out in the math. Okay. So I'm going to start with V. So I'm going to do sums of interior angles. And because we're dealing with quadrilateral, we know the sums of a quadrilateral add up to 360 degrees. So now we would subtract all our interior measurements. Okay. So we find out that V, okay, is equivalent to 108 degrees. Okay, and then again, you could have solved sums of exterior angles, or you could have solved it by complementary angle to y. So there's two different methods now at this point to solve that. So I'm going to just do a complementary angle. Okay, so 180 degrees, subtract the 108. Okay, leaves us with y equaling 72 degrees. So that's one of your first lessons of your ISU. So you'll be also working on this homework as well.